Leland Melvin, former NFL player, engineer, and now NASA astronaut. NASA is looking for the next generation of explorers, and I'm here to promote careers in science, technology, engineering, and mathematics. In today's special edition of NASA Connect, host Jennifer Pulley will show you the world's premier space convention. It's called World Space Congress 2002, the new face of space. You will see how science, technology, engineering, and mathematics are being used to develop the world's vision of space exploration over the next 10 years and beyond. You'll see great exhibits, new technologies, and students who are dreaming of becoming the next generation of space explorers. Bianca Baker from the NASA Sci-Files will be on location to show you a really cool math game called Tivi that will enhance your basic math skills. See students compete in the Tivi tournament in cooperation with NASA. All this and more here on NASA Connect.
Jennifer Pulley, and welcome to NASA Connect, the show that connects you to the world of math, science, technology, and NASA. I'm here in Houston, Texas, at the World Space Congress 2002. Let's take a quick preview of what we're going to see. So, what is World Space Congress? Well, it's the largest scientific, technical, and space exhibition event ever. More than 13,000 international space leaders in industry, science, and engineering have gathered right here in Houston, Texas. It brings together international space leaders and decision makers to share their knowledge and experiences, providing a guiding vision for an improved future. The very people who will populate that future and serve as its leaders are the world's brightest and best students and young space professionals. In fact, this global event brings together over 10,000 educators, young professionals, and students from more than 30 countries. And speaking of students, hey, look who's here. It's Bianca Baker from the NASA Sci-Files.
Hey, Jennifer.
Hey, Bianca. Shouldn't you be in school?
My math teacher asked me to stop by and check out some math activities to bring back to the classroom.
You know, that's a great idea. There are so many math activities here.
I heard about a math tournament called the Tivi Tournament in cooperation with NASA. I think I'm gonna check it out. Fill you in later.
That sounds great. While Bianca checks out the math tournament, let's visit some of the exhibits here. Hey guys, we're here at NASA's commercialization exhibit, and I'm here with Mike Weingarten, and he works at NASA headquarters in Washington, D.C. Now, Mike, when I hear commercialization, well, what is commercialization? I think of TV commercials.
Nah, that's not exactly it. What our program does is we actually work to bring space technology back down to Earth so that people can buy products made from space technology and use it in their everyday lives.
Any people?
Yeah, we've got a whole wide range of products that we're working on or that we've developed in the past. Well, here are some really neat things. Just as an example, NASA developed the anti-fog coatings that are currently being used in ski goggles that you can buy at your local store. Those come from the shuttle main windows. We also worked on gold coatings for sunglasses that come from the visors that the astronauts currently use. And then another really interesting story, you can actually go out and buy clogs right now that were developed from foams developed to protect the astronauts from the G-forces when the shuttle is launched. So you see, Jennifer, these are just some of the cool things that we're working on at NASA.
Man, you guys are working on awesome stuff. Well, you know, I'm going to spin off to another exhibit. Okay, we're here with Sharon Cobb, and Sharon's from NASA Marshall Space Flight Center in Huntsville, Alabama. Now, Sharon, it kind of looks like we're inside the International Space Station.
Well, we're actually in a mock-up of the space station. This is the way we show people what kind of experiments we're going to be doing on the space station. This is the U.S. laboratory called the Destiny module.
Great. Now, what are you working on?
We're working on racks that house experiments that we do in the microgravity environment, and there are 24 racks in the U.S. laboratory. They're on the ceiling, they're on the floor, they're on both sides, but it doesn't really matter because the astronauts can operate from anywhere because gravity doesn't pull them down to the ground.
Wow, so there's 24 racks in this particular module.
In the U.S. module.
Okay, and is this particular rack important?
This rack is important for several people. In fact, it's important to everyone because we're going to be processing material science. Material science is something that touches everybody's lives because it involves materials that go in cars and airplanes, even in the computers that we use every day. They all are based on material science. So we're looking at this rack to understand some of the problems that occur when we form these materials on the ground so that we can produce better materials on the Earth.
Okay, and so tell me about what do you mean by doing things to these materials? I mean, what do you want to do? How can you are you trying to make them better?
We're trying to make them better. We're trying to understand some of the problems that happen when you process them on Earth, like light things float to the top and heavy things drop to the bottom of a container. And in the microgravity environment, we don't have that problem. Everything stays mixed up.
Wow. Now, I'm going to ask about mathematics here because it's very important. Is mathematics important in what you do in material science?
Mathematics are important in everything, but it governs everything we do in these racks. It looks at how heat gets moved from one place to another. There are equations that govern that. There are equations that govern how liquids move around inside these experiments. In fact, there's a whole group of people that on computers actually grow materials and grow crystals based on mathematical equations.
Oh, that's so cool. Now, my final question is, what do you think is the future of material science? I mean, obviously, you're going to be taking them up into the International Space Station, but long term?
Well, what we hope to do here is gain a lot of knowledge and information that helps us to produce better materials on the ground. And in fact, what we're hoping is that we'll help make some of the discoveries that help us achieve space flight to long duration orbits, like to Mars maybe someday. We have a lot of things that we have to solve and understand before we can do that. So hopefully material science will help play a part in that.
Thanks so much, Sherry.
Thank you.
Why are we doing space research?
I remember when my kid, many years ago, asked me why Columbus went to America. I told him because at Columbus time, there was no refrigerator. And he said, oh, what do you mean? At that time, to preserve the food, it was necessary to have spices. And Cristoforo Colombo was going to find new lands where they could take the spices. So what do I mean with this story? That for every research that we are thinking to do, there is always another part of the story that we have to keep in mind. And it is the fact that for every research we have a counterpart here. We are going to go to Mars. It will be impossible to go there if we do not solve some specific problems that we have now and we will continue to have in the future on the Earth. I mean, going to Mars means problem of long-term isolation, problem connected to the loss of calcium. An astronaut loses 1.5% of calcium a month, and this is a lot if you take into account how long does it take to go to Mars. You know that 50% of the population on the Earth after 50 years old will suffer of a specific problem which is called osteoporosis. Osteoporosis is a disease connected to loss of calcium in the bones. If we found a way to solve the problem of loss of calcium when the astronauts are going to Mars, we will solve the same problem for a million of persons here on the Earth.
Hey guys, we're here at the NASDA exhibit. Now, NASDA stands for the National Space Development Agency of Japan, and NASDA is Japan's core space development program. It's a simple analogy. NASDA is to Japan as NASA is to the United States. And I'm here with Mr. Kitahara. Mr. Kitahara, what is Japan's role in the International Space Station?
We have three roles. First, we are developing a GEM, which is attached to the space station. GEM stands for the Japanese Experimental Module. Second, we are developing a centrifuge accommodation module for NASA. We place for Kibo. This is a very unique facility that generates artificial gravity to experiment how microgravity affects biological processes in a space environment. Third, we are developing a logistic vehicle. It will transport the batteries, experimental payloads, and water, which is needed for space station operation.
In your opinion, how is space research important to us right here on Earth?
I think the space research gives us a lot of beneficial things to us. For example, let me give you some example. It will produce the light-weighted metal, new medicine which is needed to cure the very difficult diseases.
Does mathematics play a key role in space research?
I think it does. To design experimental module, we have to calculate. And we cannot understand phenomena without mathematics. We need to analyze the data obtained.
And a final question, Mr. Kitahara. What do you think space exploration will be like in, say, 10 years?
Well, it's a difficult question, but I feel 10 years is long, 10 years short. It depends. About 30 years ago, Apollo astronauts landed on the moon. I think that was the first space exploration. And I think it will need more time to explore beyond that. But I think the preparation for that will begin within 10 years. I think such a huge program will never be realized without international cooperation. And I think it's a young generation to realize it.
How is math involved in the future of space transportation?
Hello, I'm Anna Ratzman. I'm working for the Swedish Space Corporation. I'm an electrical engineer, and I've been working as a designer, as a system engineer, and as a manager. You need a mathematic to be able to design the satellite, to be able to know how to launch it into space, and also to be able to understand the data that you get back to solve the problems. Right now we have a satellite, Odin, and looking for ozone holes. You know, I have 2 children of my own, and in your age, and I'm worried about the pollution, how we use water, and I think we can use space to get the right answer in this. I just would like to say this. You need the math to be able to ask and understand the big questions.
We're here at the NASA Ames exhibit at World Space Congress, and I'm here with Kevin Bass. Now, Kevin works at NASA Ames Research Center in Moffett Field, California. Kevin, tell me some of the cool things that you're working on.
I get to work with a lot of fun toys, but one of my favorites is the PSA, the Personal Satellite Assistant.
Tell me about the PSA.
The main goal of the PSA is to be a Palm Pilot, if you will, for each astronaut. So hopefully, each astronaut will have one of these on the International Space Station. It'll fly around like a little buddy up on their shoulder, and it'll have a wide array of sensors and other features, things that it can do. So one of them would be video teleconferencing. So we can use this with anybody in the mission control or with somebody, say the scientists that are on Earth. So while the astronauts are working on a specific science experiment, the scientist can actually interact with the astronaut while they're doing the experiment.
So can it talk to the astronauts?
The PSA can take voice commands, so if the astronaut is curious about a specific compartment, it can fly to that specific compartment and take temperature readings or what other type of sensor readings that it needs to, and then dictate back to the astronaut what's happening. Possibly in an event of overheating or things like that, it could also turn fans on and off or open and close hatch doors, things like that.
Now wait a minute, you said this is going to fly around? How is this going to fly around the International Space Station?
Well, there's many different ways that it flies around. It has a wide array of infrared sensors, as well as the cameras and a few other functions inside that it can use to fly itself around the International Space Station.
So it doesn't use fuel to propel itself?
It's propelled by fans. So there's 12 fans on here, and each set of fans moves it in a specific direction.
So I guess robotics plays a really big part, will play a really big part in the future of space exploration.
Absolutely. Robotics is the #1 way to explore space without putting human lives in jeopardy.
I agree. Thank you so much, Kevin. We appreciate it.
Sure.
Well, let's see where we're off to next. Well, we just left Kevin and we've moved around the NASA Ames exhibit, and I'm here with Jim Murphy, who works at NASA Ames Research Center. Jim, what are some of the technologies you're working on?
We have here one of the 5 tools that we're working on for the Mars Exploration Rover project at JPL. This is called the MER board.
MER stands for?
Mars Exploration Rover Project. This is an advanced electronic collaborative whiteboard. We have the ability to pull up images from the scientific database. You see a typical image here, and then draw those into the whiteboard space, where with a set of tools the scientists can mark this up, point out targets, and interact and use this as their planning tool. Okay? And the other feature of this is the ability then to save what they have done with these images and share them to the different groups, the other planning groups. So again, it's a very interactive, collaborative tool that will be used in the very short operational planning cycle every day for MER.
Now, how do the scientists and engineers that are working on the MER project actually get the information from the Mars rovers?
It's actually quite a complex process. The rovers are on Mars and have their storage of data and then radio links, and those radio links go up to orbiters that are in orbit in Mars, and also in some cases direct to the large antennas in the Deep Space Network down on Earth. In any case, all of the data comes down to the Deep Space Network, and then over a network is sent to the operations center in the data center at JPL, and finally into databases and files that store the data and can be accessed with the kind of tools that we talk about. So it's quite a complex process. On a daily basis, the scientists and engineers have to retrieve this data, assess it scientifically, engineering-wise, and then again plan the next set of commands and sequences for the rover and take into account what kind of transmission capability they'll have, and in fact to get data back again from the rover. So they have to take all of these factors into account in their daily operation.
Sounds like the scientists and engineers are in a time crunch.
And they're in a time crunch. They literally have several hours every day to go through this process.
What is space transportation going to be like 10 years from now? What would you like to see being done in space in the next 10 years? How does math play a key role in your research?
When do you think we'll be going to Mars?
Hi, my name is Steve Cook. I'm the Deputy Manager of the Advanced Space Transportation Program at NASA's Marshall Space Flight Center. We're responsible for developing the next generations of reusable space transportation systems to make it much more safe, affordable, and routine to get to space, along with getting in space much faster between Earth and the outer planets and beyond. Math is critical to the future of space transportation. We use math every day in developing new trajectories that'll take us to orbit. We use it in developing new propulsion systems and computational fluid dynamics. From research to test, math factors into everything we do. 10 years from now, we envision that we'll have much safer access to space through our second generation reusable launch vehicle. As we look to space propulsion, we've got some exciting things that are going on. We look to being able to move faster between Earth and the outer planets through advanced electric propulsion, through advanced fission technologies, and within Earth's orbit with advanced tether technologies 10 years from now. We're developing the building blocks for you, the next generation of space explorers.
I'm with Dr. Joel Levine. Dr. Levine works at the NASA Langley Research Center in Hampton, Virginia. Dr. Levine, what kind of a plane is this?
Jennifer, this is an airplane that we hope one day will fly through the atmosphere of Mars to study the atmosphere, the surface, and the interior of the red planet.
Wow, I mean, the plane will be exactly like this?
Actually, this is half scale, so the real airplane will be twice the size.
Dr. Levine, exactly how will this plane survey the entire planet of Mars?
Well, it won't survey the whole entire planet of Mars, Jennifer. It will fly regional scale distances. It will fly about a mile above the surface of Mars. It will measure gases in the atmosphere. It will measure the composition and mineralogy of the surface. It will take photographs of the surface, and it will measure the magnetic field in the surface of Mars.
Will this vehicle be manned?
This is a robotic mission. The whole mission will be pre-programmed by an onboard computer, and it will determine the whole sequence of events.
Now, tell me a little bit about mathematics. I mean, do you think mathematics plays a key role in having a plane such as this one survey Mars?
Yes, Jennifer. In fact, mathematics is very important because mathematics determines where we send the plane into Mars, how the orbit is determined, and where the airplane will fly. The trajectory of the spacecraft to Mars is based on celestial mechanics, which is all mathematics. And the area on Mars where the plane will fly is all determined by mathematics. Mathematics is very important to get the airplane to Mars, and then once in the vicinity of Mars, to fly through the atmosphere.
What is the time frame for having this plane survey Mars?
We think we can launch in 2007, and about 8 or 9 months later, fly through the atmosphere of Mars, 2008. And interestingly, just about 100 years after the first flight of a powered plane on Earth, the Wright brothers. This will be a very exciting way to commemorate this very historic event in human history.
All right, so let's go beyond 2008. What do you think is the future of space exploration?
Well, up to now, we've put orbiters around planets, we've put landers on the surface and rovers on the surface, and now we're talking about a brand new technology, the use of airplanes for scientific exploration, to do things that you can't do from orbit and to do things that you can't do from the surface. We believe airplanes are the scientific platform of the future to explore planets that have atmospheres.
At World Space Congress 2002, not only are there tons of exhibits, but there are lots of students and young professionals here. I'm here with a group of students called the Space Generation Advisory Council, and we're going to talk to them and find out exactly what they do. This is Shane. Shane, tell me about this program.
Thanks, Jennifer. I'm with the Space Generation Advisory Council. We represent the world's use on various types of space activities. We also work on many different projects throughout the world. 2 of them include a bus trip across Africa to teach African youth about space. The second project we do is to distribute telescopes to inner-city use across the United States.
This past weekend, the Space Generation Advisory Council held the Space Generation Summit, where we gathered over 200 young people from 47 countries around the world to come up with a vision on the future of space exploration. These people came up with projects, ideas, so that we can get into space now.
Coming to the Space Generation Summit has been a fantastic opportunity for me because I get together with people my own age who are as enthusiastic about space as I am. Together we've put together some plans on how we're going to get to space, and one of them includes developing a centre to work on space propulsion. I believe that space travel should be as easy as catching a bus, and together we're going to make that happen.
During the Space Generation Summit, we shared the definition of ethics and human rights in outer space activities, and we found out how to protect the space environment for all of us, including space generation, next space generation, and in currently developing countries.
Well, at Space Generation Summit, my working group focused on space to enhance life on Earth. And basically, the main topic was to use mobile and satellite communication in terms of disaster management and emergency relief in developed nations, to use the available information that is provided through the satellites and NASA and ESA.
We believe that every child all around the world should be educated about space.
You know, I haven't seen Bianca in quite a while. I wonder what's going on at the TIVI tournament.
Hi, Jennifer. I'm here with 30 kids from the Houston Independent School District in Houston, Texas, taking part in the TIVI Math Tournament in cooperation with NASA.
The game is called Space TIVI.
It's an exciting math-based strategy and critical thinking game that will enhance students' basic math skills of addition, subtraction, multiplication, and division by using decimals, fractions, percentages, integers, square roots, and exponents. The list of materials you'll need for this activity can be downloaded from the NASA Connect website. Organize students into groups of 2. Distribute a game board and the necessary materials for each group. Each player selects a Tivit color piece or movable playing piece. The white Tivit player moves first. The gray Tivit player gets the last move if a legal move is available. There are 4 legal moves. You can move forward 1 diagonal space, jump over 1 Tivit, jump 2 or more Tivits of either color in 1 turn. To do that, there must be an empty goal between jump Tivits. And you can move onto or jump through a black hole goal. Remember, you cannot move a Tivit piece sideways. You cannot move into or jump through your opponent's 7 exclusive score goals. You cannot move into or jump through your opponent's home base. Or you can't jump over a vacant goal. Choose a game sheet that you want to play. There are different game sheets to choose from depending on what basic math skill you want to address. Choose the Tivit symbol and numbers you want to use with the game sheet chosen. For example, use the Tivit sets for answers without remainders. Using these Tivits may have answers with remainders, or you can play with the whole number rounding. The game is over when one player captures all 7 exclusive score goals and the 2 common score goals are captured, or when neither player has a forward legal move. Students will then fill out the score sheet. Make sure you double check your answers because once the score sheets have been filled out, students will exchange score sheets and check each other's work. For advanced playing, using the forced jump, blocking, or trapping, check out the Educator's Guide, which can be downloaded from the NASA Connect website.
So what do you think of this really cool math game?
I like it because it makes you think a lot, and you have to position the players exactly where you want to put the players on the board.
I like this math game a lot because at the beginning of the year I didn't understand fractions and decimals, and our math teacher introduced it to us. I really like it. It's really fun.
Well, Jennifer, I can tell you these kids had a great time playing this game. Back to you.
Well, that wraps up another episode of NASA Connect. We'd like to thank everyone who helped make this episode possible. Got a question, a comment, or a suggestion? Then write us at NASA Center for Distance Learning, NASA Langley Research Center, Mail Stop 400, Hampton, Virginia 23681, or send us an email at connect@larc.nasa.gov. So until next time, stay connected to math, science, technology, and NASA. And where do you think space exploration will be in the next 10 years?
How this?
And NASA is the core of Japanese space
I'm working at the Swedish Space Corporation. It's a company from Sweden. We are mainly
How do you think space reach? Now they're on the ground. I mean, why would we want to bring them up to Earth?
You want me to do it? Oh.
When do you think we'll be going home?
Captioning funded by the NAC Foundation of America.